In this video, we introduce a new framework for describing and analysing cross-border impacts of climate change. The framework has been developed within the context of CASCADES, a European Commission-funded project involving 12 international partners under the Horizon 2020 Research and Innovation Programme. Climate impact assessment is commonly carried out for understanding potential risks of climate change and the possible need for adaptation. Conventionally, impacts of climate change that are evaluated for a given region are associated with changes in climate in the same region. For example, there have been multiple instances of river flooding in different European countries in recent years, and these types of event are projected to increase in magnitude and frequency in some regions. Examples of impacts associated with flooding include damage to infrastructure, losses to agriculture and horticulture, a disruption to transport and business, and a range of health effects. Adaptation measures typically include flood protection, land management, and altered building regulations. These are commonly organised within the same national or regional jurisdiction in which the climatic events occurred that were responsible for the flooding. However, the conventional approach to assessment typically ignores impacts that originate from climate-related events occurring at locations remote from a region of interest. In some cases, such cross-border impacts can severely disrupt societies and livelihoods, and adapting to such impacts requires an understanding both of the cross-border transmission of impacts and of the options available for responding to them, often also requiring actions across borders. To use another flood-related example, in 2011, Thailand experienced the longest duration flooding event ever recorded in the country, which extended over 5 months. Aside from severe local impacts, including over 800 fatalities, impacts were also felt outside Thailand. 7 large industrial parks were inundated, which manufactured electronic and automotive parts at critical nodes of global supply chains, leading to enormous production losses, especially for Japanese multinational companies. Effects were felt worldwide, including in Europe, both through price rises and delayed delivery of products. Immediate emergency aid was one possible response, and manufacturers scrambled to identify alternative suppliers. Japanese companies also made additional provision for stockpiling of critical components. These examples then illustrate the difference between a conventional impact assessment, shown schematically on the left here, where both the impacts and responses take place within much the same jurisdictional region, and a cross-border assessment, shown on the right, where impacts are remote from responses, and both may be transmitted across one or more borders. So now let us construct some vital elements of a conceptual framework for describing and analysing cross-border impacts of climate change. Climate change is associated with slow trends, which may also include changes in the magnitude and frequency of extreme weather events. We refer to both as climate triggers of potential impacts. One key challenge of this research is to establish whether or not a climate trigger causing impacts can be associated with anthropogenic climate change. Making that connection is referred to as climate attribution and is the focus of intensive research by climate scientists. These climate triggers, such as heavy precipitation, heat waves or storms, in combination with other preconditioning exposure or vulnerability, can result in impacts, initially in the places where the climate trigger operates. For example, a flood event inundating and closing factories, a drought event reducing crop yields, or a storm event damaging critical infrastructure such as buildings, transport links, or telecommunications. Some of these initial impacts may transmit knock-on effects to other systems and via other regions. We call this propagation of impacts the impact transmission system. For instance, reduced yields due to drought of a staple crop like wheat in an exporting region may depress wheat supply and increase global prices. This price inflation may be amplified through government intervention by the exporting country to protect domestic supply. High prices may then lead to food scarcity in regions that are dependent on food imports, with increases in food poverty and possible confrontation. Such processes of impact transmission can be highly complex, occurring through multiple channels at different rates and affecting a range of actors in different regions. Impacts occurring at any point in the impact transmission system are themselves very likely to be subject to local responses of the type we described for conventional impacts. However, our focus here is on the aggregate impact that may be transmitted into a region of interest. This is defined as the recipient risk. Risks are potential impacts that are often adverse, though not necessarily so, as opportunities can also arise. However, regardless of the types of impacts, they may require some kind of response or adaptation to offset damage or exploit potential benefits. The options available for responding to the recipient risk in a region of interest are shown as the green area in the figure. Responses can be reactive at time t2 after a given impact, or anticipatory at time t-1 in expectation of future impacts. Responses may be designed to fulfill a number of objectives. For example, one objective could be to manage the risk by slowing, reducing, or blocking adverse impacts, or facilitating positive impacts as they propagate through the impact transmission system. Responses might also be directed at the source of the initial impact. The responses may be targeted at the point of receipt by altering local exposure or vulnerabilities to impacts that have been received or might be received. Then again, the response could be indirect via a third party or external system, for example, by influencing other actors to intervene in the impact transmission system, or by spreading the recipient risk among additional substitute systems. The ability of a regional actor to manage the consequent risk of cross-border impacts depends on that actor's sphere of influence relative to the impact transmission system and the wider context in which the risks are generated. This sphere of influence is represented by the strength of green shading in the figure. For instance, a country may exert more political and economic influence on a distant trading partner with which it has a long-standing trade relationship than it does on a nearby country managing the transit of commodities in a supply chain affected by a remote climate event. A final note here is that one response not depicted is to mitigate the causes of climate change through greenhouse gas reduction. However, while such actions are vital as a policy measure, outcomes of mitigation would normally be felt only over longer timescales. As such, they are not considered here. In reality, multiple cross-border impacts are taking place in the wider context of an interconnected and ever-changing world. The impact and response transmission systems that directly affect the recipient risk can be expected to interact with these external systems, which are shown in yellow in the figure to represent the present day. Since the environment and society are constantly evolving, this will affect the context in which future risks due to cross-border impacts will occur. Uncertainties in how this evolution will occur can be represented by alternative scenarios or storylines. These can be scenarios of environmental change, affecting the climate triggers of initial impacts, and of socio-economic development, affecting the propagation of impacts as well as potential interventions. These scenarios or storylines are represented as stacked rectangles in the figure. The framework we have presented is a conceptual simplification of reality. In order to understand how the processes of cross-border impacts may materialize so that we can design appropriate responses, it can be helpful to characterize the separate elements and their assumed causal relationships. First, we recognize that there are numerous categories of cross-border impacts. These have been classified in various ways in the scientific literature, and we have adopted 7 categories here. These are trade, for example, flows of commodities on international markets; finance, the movement or change in value of public and private capital; people, movement of people across borders such as through migration and tourism; psychological, impacts brought about by actions of different actors based on their perceptions and communication of cross-border risks and opportunities; geopolitical, for example, climate-related impacts on international relations, resource access, and strategy; biophysical, for example, water transfer among hydrological systems and movement of species, pests, or pathogens; infrastructure, such as transport and communication links. Next, let's make a distinction between 2 broad types of climate trigger. Short-period weather shocks can be individual events such as a flood or storm or drought, consecutive events such as a river flood followed by a coastal storm surge, or simultaneous teleconnected events at distant locations related to a single cause, such as extreme weather in different places associated with El Niño or La Niña conditions. Slow onset events are longer period gradual changes in climate that may lead to more frequent exceedances of critical thresholds of impact. For example, shifting zones of crop suitability due to warming and drying that decreases productivity over time in core production areas. The next set of illustrations depict alternative configurations of the impact transmission system. The upper 5 examples show some of the scales at which impacts may be transmitted following an initial impact. This relates to whether the cross-border dimensions are across neighbouring regions or remote regions, and describes the number and nature of regions over which impacts are propagated. The lower 5 examples offer illustrations of different impact transmission dynamics, describing cascading tiers of impacts, cascades where impacts escalate or diminish, examples of feedback mechanisms, and of compound impacts. Finally, we illustrate some different types of targets and dynamics of response transmission systems. The upper 4 examples depict responses that are targeted at the initial impact, at the impact transmission system or its individual components, at the location of the recipient risk to reduce local exposure and vulnerability, or via a third party to ameliorate the risk indirectly via an external system component. The lower 5 examples show how the transmission of responses to ameliorate propagating impacts can be complex. Sequential recovery has responses staggered over time. A block prevents further propagation of impacts. Substitution spreads the risk via an alternative external system component. Variable influence relates to the sphere of influence of the actor managing the recipient risk. Group of actors shows how the same impact transmission system may pose risks for different recipient actors, who may respond individually or collectively. We should emphasize that these typologies provide merely a flavor of the possibilities and are not intended to be comprehensive. Finally, let us illustrate how the conceptual framework and elements of the typology can be used to represent real-world examples of cross-border impacts of climate change. Here we present 2 examples. First, impacts on supply chains of the 2011 Thailand flooding example. Second, potential cross-border impacts of retreating Arctic sea ice. We already used the Thai flooding example to illustrate cross-border impacts of climate change on supply chains. Here we apply the conceptual framework and elements of the typology to formalize some of the impacts and responses that were reported. Note that the region of recipient risk here is Japan rather than Europe, as the manufacturing companies most affected were Japanese-owned multinationals in the automotive and computer electronics industry. The 3 main categories of cross-border impacts described here are on trade, infrastructure, and finance. The climate trigger was a short-term weather shock comprising a compound event with an unprecedented amount of rain falling on an already saturated land. This phenomenon is thought to have been exacerbated by anthropogenic climate forcing. The initial impact was severe flooding, with inundation due to poor flood defences made worse by land subsidence, indicating a failure by overseas investors to anticipate the high flood risk when locating facilities in the region. Low effectiveness at accessing alternative supply networks and procurement sources disrupted the supply chain, causing component prices to spike. As a result, Japan's manufacturing index for the last quarter of 2011 shrank by 2.4%. In response, Japanese companies made additional provision for stockpiling of critical components and sought substitute suppliers. Meanwhile, the Japan International Cooperation Agency invested in a flood management plan for enhancing resilience in the region. The Arctic sea ice example differs from the Thai flooding example in one major respect. Here, many of the cross-border impacts of climate change have not yet been observed, but rather are anticipated for the future, though some impacts are already ongoing. The categories of potential impacts are many, including trade, infrastructure, people, psychological, geopolitical, and finance impacts. The climate trigger in this case is rising temperatures in the Arctic, a slow onset event whose initial impact is the gradual retreat of sea ice. The opening of coastal regions and of previously inaccessible natural resources presents an opportunity for exploitation, requiring psychological recognition of this, followed by concrete responses from multiple actors propagating through an impact transmission system. There are new possibilities to invest in Arctic infrastructure to facilitate resource extraction, opening of trading routes, and tourism, activities which would also introduce acute hazards to the fragile Arctic environment. Policies to protect EU interests in the Arctic, the recipient risk, will be tested as international activity in the region is stepped up. Responses may include diplomatic efforts to forward EU interests, investments in some of the economic opportunities, as well as policies to protect the Arctic environment. So, to summarise, we have presented a conceptual framework for describing and analysing cross-border climate change impacts and responses. We've demonstrated its application for two cases of cross-border impacts, one due to a weather shock in the past, a second anticipated due to a slow onset event that is ongoing. The framework is currently being applied in the CASCADES project to investigate a range of prospective cross-border impacts and responses.